Alright, so this is the second method where you can write it iteratively and just immediately convert that code from an iterative version into a recursive version. So let's just try to take it from in a backwards fashion, starting from n, right, and keep on decrementing that n up until we reach actually 0 in this case. So this is going to get you 20 in this case, right? If you are writing this recursively, notice that this is the same operation that you're going to need, right? And notice that this is going to be wrapped inside a function that maybe is called SumEvens. I'm just going to have this like that because I did another one with the same name earlier, right? So this is going to take an n, right? So what you will do typically is that you're gonna take every n, you're not gonna need an I here, so you're gonna take every n and add to it the accumulative value, right, which is in this case something like s, right? But the accumulative value, as I told you, is an unknown value for you, and this is not gonna be found in a variable or so. It's gonna be found from a returned recursive call, right? So this is going to be a return found from a return recursive call. So this n maps to I and this s maps to SumEvens, right? So you're going to return whatever is going to be whatever value that's going to be returned from that line, right? And every time you decrement with -2, you're going to be calling the function. So this is the same thing, right? And you're going to stop when you reach, for example, 0 or 2, as we said in the previous video, right? So if n equals to 2 or 0, let's say 0 but 2 is better, of course, we're going to return the value of 0, since this is going to affect the summation. If you have this as 0 and if you have this as, for example, any number, 0 is not going to affect anything, right? So let's try and call SumEvens and pass to it 8. It's going to get you 20. Now I don't really like this kind of way of thinking, because to me this is easy to think of, right? Because I'm already familiar with the concept of recursion. If you are not familiar with the concept of recursion, meaning that the giveaway here is that you didn't understand what I've just said in this 2 minutes or so, please watch the first method, which is depending heavily on the call stack, right? If you understood this via the call stack, then this is just a child play for you, right? If you wanted to take it from like literally how the loop is taking this, let's say that we wanted someone is not going to start with, for example, someone is not going to start from the greatest element, and we just want to take the loop starting from the smallest element, which in this case is going to be 0, right, plus 2 up to n plus 1. So this is going to give you 20. If you wanted to do the same thing, the same exact thing, right, so you would do something like this. All right, I want to have I don't want to discard this I and depend heavily on n. Well, in this case you can do the same thing. You can say SumEvens version 2, right, which is gonna be taking n as well and is gonna be taking I. And notice that if we put I to start from 2, it's gonna give you the same result. So I optionally, this is an optional parameter starting from 2, right? So we know that if I here, what is the condition that I'm breaking the loop on? Where the condition is basically when I get to n that is equal to 8, or typically where I gets to be equal 8, which is in this case equal to n. So if I became equal to n, notice that we are going to increment the I is going to be 2, 4, 6, and 8. Then we can safely assume that we can return this I or this n. It's the same in this case, right? And here, of course, there's a conditional where I check if this is odd or even, but I didn't place this in this code, or I'm not gonna place it in this code as well. I just want to do this video as fast as possible. So in this case, we know that any I that I reached, if this, for example, 2, or for example 4 or 6 or 8, I'm going to add to it the accumulated value inside S, and that accumulated value is gonna be fetched from the recursive calls to SumEvens version 2, right, where I'm going to pass the same n, because the same n needs not to be changed. Hence, I want to have this condition checked at some point, at the last iteration, at the base case, right? So n needs not to be changed, right? But what will be changing, just as the same fashion here in the loop, is that I is going to be decremented, or I'm sorry, I is going to be incremented or increased by an addition of 2's, right? So we're gonna increment the I with 2 in every recursive call. What this will return is gonna be serving me to have the final result, right? So now I can just say print SumEvens version 2 and give it 8 in this case, right? If you don't understand what's going on here, and then I'm just gonna say that I have a couple of stack frames. So the first call, this is, for example, this is my driver code. I'm gonna do the same thing that I did for the factorial program. This is the first recursive call, RC1. So the first recursive call, or RC1, in the stack frame is going to be having the same function definition, but here you are, look at what you're passing n that is equal to 8, right? So here n is going to be equal to 8, so this is going to be substituted by 8, and this is going to be substituted by 8, and notice that you short the I with actually 2, right? So I is going to be 8, and notice that you are going to return n, which is in every recursive call is going to be the same as n, since n doesn't change at all. And this is going to be 8, and this is going to be incremented by 2. So let's see, before we get to the next recursive call, or RC2, let's see this. Is I that I started with as 2 is the same as 8 that I've passed as n? Well, no, this condition is not going to be working, since and then the interpreter is going to go to this line and try to execute it. It's going to substitute this I with 2, and it's going to find that there is another call for that function. So a new stack in the stack frame is going to open up to that recursive call, right? So a new stack, a new recursive call is going to be opening, and this n is going to be 8. Notice that here n was 2, and notice here that we are opening this recursive call, we are calling this function with a value of n that is now equal to, if we started in with 2, then n plus 2 is going to give you 4, right? So now in this recursive call, I'm talking about I here, I is going to be equal to 4, right? So is I 4 equal to 8? Well, no, since they're not equivalent to each other. Then the interpreter is going to go to the third, or the third line here. So it's going to evaluate I with 4, and it's going to find another call. So it's going to call the same function again, right? With n that is equal 8 and with I that is equal 6 in this case, right? So another recursive call is going to be opened up on the stack. So this is recursive call 3 with the same n that is being passed, and the I that is being passed is basically equal to 6 in this case. Is 6 equal to 8? Well, unfortunately it is not. It's not equal to 8 at all. So let's evaluate this line. So this is I, this is 6, and in this case I is going to be incremented by 2, so this is going to be 8. So another function call is going to be happening, since the interpreter is going to hit this line that has another function call, right? So this is recursive call 4, where n is equal to still 8 and I is now equal to 8. So now is 8 equal to 8? Well, yes, it's equal to 8, right? So this is not going to be executed, since this return is going to be returning 8, and all of this recursive call is going to be pumped up the stack, but what is going to be returned from it is basically this 8, which is going to take place of the recursive call that has already called it from the previous stack frame, or from the previous recursive call. So this is going to be substituted by 8, which is going to give you 14 in this case, right? So this is going to give you 14, right? So once this is returning 14, then this is going to be popped up the stack, and where this function call, or this recursive function call, has been triggered, which is basically in this line, this highlighted recursive call is going to be substituted with the return value, which in this case 14, right? So let's see, this is going to get you 18, right? So let's see, where should we return that 18? Typically to the place that this function call was called from. So this is going to pop up the stack, and that 18 is going to be placed in that highlighted function call, which is 18. So this is going to end up with 20. So this is going to be returned, this is the first recursive call. So this is going to be popped up the stack returning 20, and 20 is going to be placed inside or in place of this recursive call, or this function call, and that's why you see 20 being printed.